Let's try an example. So here we're going to find the most general antiderivative for each of the following functions. And let's start with the first one here, the constant function 5. So when we see this kind of terminology here, find the most general antiderivative, what that's really telling us is find the indefinite integral. So that's what we're going to do. We're going to calculate the indefinite integral of the constant function 5. We're going to do this with respect to x, and we know with respect to x because that's how our function is specified here. It's specified as a function in terms of variable x. All right, so we're finding the antiderivative. It's just a constant function, so what do? Well, we go back to our constant rule, which says take your constant, just multiply by your variable. So constant k times x. And that's what we're going to do. Our constant is 5, so this will just be 5 times x. And since we want the most general antiderivative, we want to remember our plus c there at the end. Okay, so that's the first one. Let's try the next one. We want to find the most general antiderivative of x cubed. Really, we want to find the indefinite integral of x cubed with respect to x. Now this is just a power function, so we're going to do the power rule. So what does the power rule do? Well, we're going to keep our variable the same. So it's an x here. We're going to keep it an x. Then we're going to add 1 to the exponent. So we're going to go from 3 and we're going to add 1. And it's fine if you want to do, as you're starting to learn this, just like when we had derivatives, it's okay if you want to show this 3 plus 1 or plus 1 when we change the exponent here. But once we get the hang of this, we don't normally write this. So for doing the power rule, I would normally just go from 3 and add 1 in my head to get 4. So I wouldn't actually show this. I would just go right to 4. And then once we have that kind of new simplified exponent, I would take that exponent 4 and just flip it, put it in front. So that's how the power rule works. We keep our variable the same. We add 1 to get our new exponent. So we go from 3 up to 4. And then I take that new exponent and I flip it and put that in front. And that's a constant that goes in front. And then, as with all of these, plus c at the end. All right. So really the behind the scenes here for this 4, this is really 3 plus 1 equal to 4. We don't normally show that 3 plus 1, but if you're getting when you're practicing, if you want to show that, perfectly fine. All right, let's try the next one. We want to find the most general antiderivative for the square root function. So really what this is saying is calculate the indefinite integral of square root x. And for these last two, we're going to use a lot of our similar strategies that we would do for derivatives. So if we wanted to differentiate square root x, what would we do? We would rewrite this first. And we're going to do the same thing here. We're going to rewrite anytime we have a root function. So if we had the nth root of something, we would rewrite this as a power function, raised to the power 1 over n. So for a square root, the way we rewrite that is x raised to the 1/2 power. So we're going to find the indefinite integral of x raised to the 1/2 power. And now we actually do the power rule. So our variable is x. We add 1 to the exponent. So let's, especially with fractions, you might want to show a little bit of this off to the side. So if our original exponent is 1/2, let's add 1. And if we're adding 1 in, we could write that as 2 over 2, so we have a common denominator. And then if we combine those and do the arithmetic, we end up with 3 over 2. So 3 over 2 is going to be our new exponent. And so the way the power rule works is we keep our variable the same, add 1 to get our new exponent, so we go from 1/2 up to 3/2, and then we take that new exponent and we flip it, and that goes in front. So we're going to put a 2/3 in front. So it's helpful to try to get this exponent first so that you can just put the reciprocal in front here. And that's power rule. And that's the power rule. And because we're trying to find the most general antiderivative, plus c at the end. All right. Last one, 1 over x squared. Same kind of thing. If we were to try to differentiate this, normally what we would do is try to rewrite this using negative exponents. And we're going to do the same thing here for finding the antiderivative. So really we want to find the antiderivative of 1 over x squared. And we're going to write that with a negative exponent. So we're going to rewrite that as x raised to the negative 2 power. So rewrite using negative exponents. These are all very similar strategies that we would do for derivatives. This is something we would do for derivatives as well. All right, so now we want to find the integral of x raised to the minus 2 power. We want to find that antiderivative. So we're just going to do power rule. So our variable is x. We add 1 to this old exponent, so we go from negative 2. If we add 1, that takes us up to negative 1. And then we take this new exponent, flip it, put it in front. So 1 over negative 1 goes in front. And if we wanted to, sometimes it's helpful to try and rewrite these back as a fraction. So we could write this, instead of x raised to the negative 1, if we wanted to, we could write this as 1 over x. And then really 1 divided by negative 1 is just negative. It's negative 1. So we could just put a negative in front here. And then we have our plus c. All right, there we go. So just a little bit of practice using some of these kind of preliminary integration rules. But we're not entirely interested, it's going to be helpful, but we want to kind of be able to integrate more functions. So far we know how to integrate power functions and constant functions. We need to learn a few more rules to kind of expand our horizons, and that's what we're going to see next.